Welcome to another episode of CCSD Earth Science. Today we're going to focus on dew point and relative humidity. These are two really important concepts that we're going to talk about throughout this unit. Okay, dew point, when the air temperature drops down to the dew point, okay, that's when we're going to have condensation form or precipitation. So that's why it's really important to know what the dew point temperature is, because it gives us an idea of if it might rain or if we're going to see dew on the grass in the morning. We can also use the dew point temperature. It relates to clouds, so the cloud formation is also because of the dew point temperature and the air temperature meeting. Okay, so right here, if we look, and the air temperature is 22 degrees Celsius, all right, and the dew point temperature is 15 degrees. That would mean the air must drop down to the dew point temperature and be the same in order for dew or condensation or clouds to form. So they have to be the same or very, very close if you're going to see condensation form. Now, relative humidity, okay? That's how much moisture is in the air, and we measure that in percent. So the highest you can have is 100% humidity. When the atmosphere is saturated with moisture, when it's completely full of moisture, it can't hold anymore, the humidity is 100%. Okay, so if you think about the air like a sponge, if the sponge is completely soaked, you just had a big spill and you're wiping it up, okay, when the air is completely saturated like a sponge, moisture starts to come out of it basically. So when the air temperature reaches the dew point temperature, that's when you have 100% humidity. And also you're going to get the condensation or precipitation occurring. So dew point and relative humidity are very closely related. Okay, now this graph right here, we've got a couple of them. All right, this top one is looking at the temperature, all right, looking at air temperature and dew point temperature. And down here we have relative humidity from 0 to 100%, all right. Now, when the air temperature and dew point temperature are the same or very close together, notice the humidity is higher. When they're farther apart, the humidity is lower. So there's a definite relationship, a direct relationship right there between humidity and the dew point and air temperature. So they're all kind of connected to each other. Now, the way that we figure out the dew point temperature is we use this thing right here that we've talked about a little bit already, a sling psychrometer. Here is another example of one, okay? And again, it's got the little handle, and you can spin it around or sling it around. That's why they call it that. You've got your dry bulb right here, and you have the wet bulb. And this is the kind like Mr. Miller showed you, okay? It's kind of enclosed in a case. And the dry bulb is up here, and it's just like a regular thermometer. And then you've got another thermometer with a little piece of fabric like this one that they call a sock. So if you see something talking about a sock, it's this right here. And you get that wet. That's why this is the wet bulb, okay? Now that temperature is always lower, all right? Think about in the summertime, you go swimming. When you're standing like on the side of the pool, before you jump in, you're hot, okay? When you jump in and then you jump back out, now that you're wet, typically you're going to feel a little bit cooler. And that's because the water is evaporating off of your skin and it cools you down, okay? Same thing with this, all right? When this is swinging around, the water is evaporating off of it and it makes this temperature lower. So what we do is we use these two temperatures and your reference table to figure out what the dew point temperature is, and we can also use it to figure out what the relative humidity is. This right here, this little chart, is right out of your reference table. And what did I do with it? Now, if you would like to receive full credit for completing your notes in class, you need to write down that this chart right here is on page 12 in your ESRT. So somewhere in your notes, write down that this is page 12 in your ESRT if you would like to receive 100 for completing this homework. Okay? Now this chart right here is basically this. This is just simplified. I'm going to go through and explain a little bit about how to use this, and we will practice it more in class. But if we take a look, we have a dry bulb temperature and a wet bulb temperature. That's what we took off of the sling psychrometer. We need to subtract those, okay? And we get a difference between the dry bulb and wet bulb. Now, on that chart in your reference table, you're going to come down till you'll find the dry bulb temperature, which is 8 degrees in this case. Then on the top, along the top, you're going to look for the difference, not the wet bulb temperature, but the difference, which is, in this case, 6. So you come across, so you'll find 6. All right? And then where the two of them meet in the middle, that is the dew point temperature. So in this case, the dew point temperature was -9 degrees Celsius. All right? And you're going to do the same thing for relative humidity. It's just going to be on the chart on the bottom. So what we just looked at is the chart right here, dew point. If you look at the bottom, you've got relative humidity there. It's the same thing. You go down, find the dry bulb, go across, and get the difference between the dry bulb and wet bulb, and then find out where they meet. And that's how you find the dew point and the relative humidity using your reference table. Now, you have to be careful because sometimes the temperatures you get are going to be in Fahrenheit. Your reference table is only in degrees Celsius, so you have to make sure that you're using the correct units. If you're trying to do this with Fahrenheit temperatures, you have to convert them to Celsius before you use the reference table.